Over the past several decades, increased lake salinity has become a major issue due to human use of road salts, fertilizers, and water softeners. Runoff and waste enter lakes, depositing salt into the water. In this situation, salinity is defined as the presence of ions in the body of water. Some common ions are Cl-, Na+, Mg+, and K+. As ions enter lakes, they settle at the bottom, causing the lower layer of water, or the hypolimnion, to become denser than the water at the top of the lake, which is also known as the epilimnion. This causes lake stratification, which is when layers of water separate due to differences in density. In this case, this type of separation is called chemical stratification. If you've ever been to a lake during the summer, you've experienced lake stratification for yourself. Shallow water tends to be warm, but as you wade further in, the water around your feet starts to become cold. This is because the sun warms only the top part of the lake. This warmer water is less dense than the cold water beneath it, causing the water to separate into two layers based on the temperature and therefore densities of the water. This type of stratification is called thermal stratification. Lakes with high salinity levels can experience both chemical and thermal stratification. If the difference in densities between the layers of water is large enough, the stratification can be so strong that lakes may not mix during the fall and spring like they're supposed to. Typically, the water throughout a lake reaches a similar density during the spring and fall as temperatures change and the lake destratifies. This allows the lake and the water to mix. One of the most significant impacts of mixing is the fact that it replenishes the dissolved oxygen at the bottom of the lake. If a lake doesn't mix, then the oxygen in the hypolimnion depletes, causing fish and other oxygen-reliant organisms that dwell in lakes to die. This lack of oxygen also causes an interesting chemical effect. Phosphorus, which is stored in lake sediments in compounds with other elements, is released into the water in anoxic conditions. One specific impact of this influx of phosphorus is the increased growth of cyanobacteria, or blue-green algae. But why are the impacts on the growth of cyanobacteria so important? Well, cyanobacteria can release toxins that harm lake-dwelling organisms and pollute the water. This also impacts us humans because it reduces access to clean drinking water and safe recreational lakes. As climate change ravages the planet, harmful cyanobacteria and algae blooms are becoming more and more common. While scientists don't have a definite answer for the cause of most of these blooms, human-caused salinity is a possibility that often isn't discussed enough. Action needs to be taken to reduce the amount of waste that enters lakes. Otherwise, soon, we may not have lake ecosystems left to protect anymore.